In this video, I'm going to be introducing you to a topic in electrical engineering called circuit analysis. And circuit analysis will help you a lot, especially when you're trying to do things with breadboards, you're trying to even make circuits in real life, right? They're basically the diagrams that show you how everything is connected and make calculations super easy, right? Because in real life, you're going to have a bunch of wires everywhere, but if you have a nice circuit out there, you can calculate what's actually going on with the electricity. So, first off, let's talk about units. First unit that we're going to talk about represents voltage, and the second we're going to talk about represents current. These are two important measurements that you need to take in circuit analysis. But for voltage, voltage is represented by V, and it measures volts. Current is represented by A, and it represents amps. Now, if you wanted to write down something had 5 volts, you write down 5V. If you wanted to write down something had 2 amps, you write down 2A. Now, don't touch anything if it says 2 amps because that's a lot. Actually, don't touch anything that has electricity going on with it. But voltage and current exist in every single element. They're going to help you with calculations. You could do math with them as well if you had operational amplifiers. All right, they're basically very helpful tools. Not helpful tools. They're basically the measurements of how electricity actually flows. All right, how about for elements? Well, an element is just a very broad term that you can use for something that isn't a wire inside of your circuit. It could be a resistor. It could be an inductor, right? It could be, I don't know, a diode, right? It doesn't matter, okay? Something that isn't a wire. So what do elements have? Well, elements have a positive and negative side. And between this positive and negative side, you can write down the voltage here represented. So if this element had 5 volts, you write down 5V. If the variable for this element's voltage is unknown, you can write down V1, V sub 1, V sub 2, doesn't matter. All right, but this right here is an element, and you also have a current that goes through the element, and the current can be represented by this line here. Now, keep in mind, this line doesn't represent the direction of the current. It just represents the direction of the measurement of the current. So, yes, you can have a negative current, right? If this arrow is pointing this direction and you had a positive current, right, it'd be, well, the current would be going in this direction. But if you had a negative current, 5 amps, and the arrow is pointing down, then the current would be going in the opposite direction. Now, usually you're going to see the arrow point into the positive end of an element. This is just called passive sign convention. It basically states that whatever direction you're measuring the current in, it just hits the positive end of the element first. Well, how about for a node? Well, if I were to draw an entire circuit here, you can draw a circuit like this, correct? Let's say this is V1, this is V2. A node is basically just a connection point for elements. So right here, these 2 points are nodes. Maybe you've had 3 elements like this. Right here would be a connection point for nodes. Let's actually use a different color. Right here would be a decent connection point for the nodes. And later on, you're going to realize that this entire bottom section, this entire top section is a node in itself. Now, nodes are going to be very important, especially when calculating things with current, using Kirchhoff's current law, Kirchhoff's voltage law, and stuff like that. Kirchhoff's voltage law is more important when it comes to the positive and negative ends, but the nodes are going to be very important for Kirchhoff's current law. Now let's actually talk about some actually important vocabulary that you're going to be using for current laws and voltage laws, the Kirchhoff's laws. So let's talk about voltage, drop, and rise real quick. Drop / rise, and current into the node. Let's just call it current in and out. So, well, for a voltage drop and voltage rise, if you had a diagram that looked like this, let's actually draw it better. If you had a diagram, that looks ugly. If you had a diagram that looks like this, and you had some positive and negative sides here, maybe negative here, positive here, you would pick a direction, clockwise or counterclockwise. Doesn't matter, right? Clockwise or counterclockwise, it doesn't matter. And you determine whether something is voltage drop or voltage rise based off of that. So if you picked a counterclockwise direction, like so, then if you move in the counterclockwise direction, you'd be going up here, you'd be going left here, and you'd be going down here, correct? These are all in the counterclockwise direction. Well, if you're going up in this direction, you're going from the positive to end to the negative end. If you go from positive to negative, let's actually write down the T with a squiggle T. If you go from positive to negative, this is called a voltage drop. And if you go from negative to positive, this is called a voltage rise. And it makes sense, right? You go from negative to positive, you're rising. If you go from positive to negative, you're dropping, right? You can think of it as maybe a number, right? You go from a negative number to a positive number, you're rising in value. If you go from a positive number to a negative number, you're dropping in value. So this is really what just voltage drop and rise is. And keep in mind, this loop will be very helpful for Kirchhoff's voltage law. Well, how about current into the node and out of the node? Well, let's actually draw a less obvious circuit, but let's say that there is a node here, maybe some elements here, right, on the ends. Draw this diagram really weird, some elements here, you know, they go off into the rest of the circuits, right? And you had currents going in, some currents going out of this node, some currents going out, some currents going in. Well, this is self-explanatory, right? The currents that are pointing towards into the node are going into the node. It's called current into the node. And the currents that are going outwards of the node, this node in the center, are called currents out of the node. Now, keep in mind, if you had a negative current here, like a negative 5 amps for this guy right here, you could simply just flip the arrow and then turn this positive if you wanted to. And now this would be considered current out of the node.